Okay, so now let's look at the generalized block diagram of a communication system. In the first video, we had just used three things to draw our communication system. Those were transmitter, channel, and receiver. Now let's be a bit more specific and give out more details. So what do we have here? At the transmitter side, we have a modulator, and at the receiver side, we have a demodulator, which is, as the name suggests, does the opposite of what the modulator does. Now, the modulator is given two inputs. One is the message signal, and the other input is the carrier signal. These two are modulated by the modulator, and then the modulated signal S of t is produced, and now this modulated signal S of t is transmitted into the channel. In this case, we are using air, free space as a channel, and here at the input of the demodulator, S of t is present, and at the output of the demodulator, we get back our message signal M of t. So what are the notations that we are using here? Let's just write them down. M of t is our message signal. We will be using these notations throughout, so we need to remember them. S of t is the modulated signal. And last, let's just use a different color over here. C of t is the carrier signal. Now the message signal M of t has other names as well. It is also called the baseband signal and the modulating signal as well. So let's just write them down. Also known as baseband or modulating signal. So what we are doing here is, if you observe from the block diagram, we are not transmitting the message directly, but we are modulating the carrier with respect to the message and producing a signal S of t, and it is being transmitted. And then at the receiver's end, so this is the transmitter's end, this is the channel, and this is the receiver. So S of t is being received over here, the modulated signal, and it is getting demodulated, and our output is our required message signal M of t. Now let's just look at the carrier. C of t, the carrier signal, is given by AC cos of 2 pi fct plus phi, where AC is the amplitude of the carrier, Fc is the frequency of the carrier, and phi is the phase of the carrier. Now what we do is, we change any one of these three parameters. We change any one of these three parameters according to the message signal. So this is called modulation. An alternate definition of modulation. The first definition which we had seen was converting a low frequency signal to a high frequency signal is called modulation. Another definition is varying any one of the parameters of the carrier with respect to the message signal is known as modulation. Now we can either vary the amplitude or the frequency or the phase. If we vary the amplitude, we get, the type of modulation is known as amplitude modulation, and it is classified into four types: amplitude modulation, double sideband suppressed carrier modulation, single sideband suppressed carrier modulation, and last, vestigial sideband modulation. And if we are varying the frequency, the modulation can be classified into two types, namely narrow band frequency modulation and wide band frequency modulation. And if we are varying the phase, the modulation can be classified into two types, namely narrow band phase modulation and wide band phase modulation. So these are the types of modulation. Totally there are 8 different types of modulation. 4 are related to amplitude modulation and the other 4 are related to the angle. This entirely is the angle, right? So these two are related to frequency and these two are related to the phase. Now up to this point, up to these 5 lectures, these 5 videos, we have just looked at the basics of what we are going to use in the subsequent lectures. Now under each and every type of modulation, we will be looking at a few things. They are, firstly, we will be looking at the time domain equation of S of t, and then we will look at the spectrum of S of t, that is S of f, and then from the spectrum we will calculate the bandwidth and power for the specific modulation type, and then we will look at the generation techniques of S of t, and then we will look at demodulation techniques of the particular modulation type. So what we are going to do is, we are going to take AM and then we are going to see the time domain equation of AM, the spectrum of AM, the bandwidth and power of AM, the generation of AM, and the demodulation techniques of AM. And then again we will go to DSB, and again we will go through all these steps, and we'll take SSB, we'll go through all these steps, VSB, all these steps, narrowband FM, all these steps, wideband FM, all these steps. Okay, so that's it. These are the basics, and from the next video we will be looking at AM. We will start AM and we'll look at all these techniques and so on.